Hello all and welcome back to Fun FTC. I'm Aabhas and with me tonight are my co-hosts Miriam and Arjun. Tonight we are kicking off our new Into the Deep season with a game breakdown and discussion show. We want to take a dive into 3 different elements of the game that we think all teams should be thinking about if they want to compete with the best of the best and give some predictions on what we think the game will be like, scoring, strategy, and all those things.
This video on fun is brought to you by viewers like you and also in partnership with the following. Studica Robotics offers durable, polished, and anodized aluminum channels with several new colors coming soon to customize your robot at studica.com/robots. No rough edges and a versatile hole pattern allows for positioning at multiple angles. Feel the Studica Robotics difference, and if you're in the USA, request a structure sample for your team at studica.com/robots. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply.
Before we jump into our discussion points for tonight, I think we should start with an overview of the game so everyone's on the same page. Into the Deep seems to be both very similar to old games and have nothing in common with them at the same time. I personally am extremely excited about this year's game. I think it's going to be a difficult challenge, and I'm really looking forward to seeing how high performing teams play Into the Deep. So the main game element this year is called a sample. It is a plastic 3.5 inch by 1.5 inch by 1.5 inch element that has concave faces on the sides. There are 80 samples in the game, 20 red, 20 blue, and 40 yellow or neutral samples. And there are also 20 clips per alliance this year, which allow human players to convert samples into specimens. These can then be scored in the middle onto the chambers. It's really interesting to be back to a game that has a lot going on in the middle, as it's been 6 years since the Rover Ruckus Landers. Into the Deep has a large structure in the middle with 3 key components. There's the submersible zone, the chambers, and the rungs. So the chambers are where specimens are hung that we just talked about. The rungs are where robots are hung. And on the 2 corners of the field, you have baskets where there are low and high baskets for additional scoring. Now, Auto and Teleop have the same objective this year of collecting samples, delivering them to human players, and making specimens and then scoring everything. And I'm a little disappointed that we won't have like a randomization task in Auto, but I do think that the points distribution for this year's game is really interesting. I think for very high scoring games, we're going to see around 50 points for Auto, maybe 150 to 200 points for Teleop, and then up to another 60 points in endgame. So, like high scores, I'm predicting to be around 300 points until February or so. And then maybe by Worlds, we'll see scores pushing that 400 limit as we did last year. But it's going to be a while before we get there, in my opinion. And now, finally, before we go and jump into our discussion points, I want to urge all teams to read the competition manual. It's a completely new document this year and has a lot of updates and new information about advancement, eliminations, information on awards, new robot rules, and of course, all of the game rules. I think that's enough talking for me. Um, Miriam, why don't you introduce yourself and then walk us through some strategies you see in this game and maybe some general robot archetypes?
All right. So the main thing I see when I look at this game is there are 2 different types of robots that a team could choose to design this season. So the first one that is a robot that focuses mainly on putting the yellow samples into baskets. So this robot would probably be a pass-through that would allow them to quickly pick up samples from the submersible and then place them into baskets. They need the ability to be able to lift pretty high because the high basket, I believe the lower lip is 43 inches off of the floor. And then the other type of robot that many teams might go for is a robot that is able to cycle specimens onto chambers. So these robots, they'll need to be very careful. They need to be in sync with their human players in order to have maximum efficiency.
Mhm.
Because the ideal cycle on this robot would be the ability to always be either picking up a specimen and dropping a sample into the observation zone, or the ability to uh, place a specimen onto the chamber and put this and pick up a sample.
Yeah.
So
And Miriam, I think we have a couple slides on the screen we can talk about, definitely relating to like the general strategy that you're mentioning here. I think there's one like very clear variant of the game where there's going to be very minimal interaction between the robots, and that's like that first time where everyone's kind of intaking from a different place and they're also depositing at a completely different place. Do you think we'll be seeing this sort of gameplay for a long time, or do you think we'll see different strategies develop?
So I mean, I think we definitely might see different strategies develop. Like, I feel like
Mhm.
every season, we've seen so far, we've come up with what the initial strategy will be, and there's always some kind of meta change,
Mhm.
throughout the
And
season.
yeah, and like in cases when there's like, one aligns with a really strong robot and one with a slightly weaker, what do you think we might see there?
Yeah, so in that event, you could probably have the weaker robot just focus on bringing samples from the submersible to the observation zone. So something
Mhm.
like that, it would allow the stronger robot. You could kind of go like in a little. I kind of think of it as a triangle. You can kind of see it on the slide. So the stronger robot would be in like a situation where. At least what I think would happen is you would grab a neutral sample from the submersible, put it in a basket, and then go to directly to the observation zone to pick up a specimen because you have your alliance partner just focusing on bringing specimen into the or bringing samples into the observation zone in order to put in order to make it into specimen, and then your stronger robot would put those specimen onto the chambers while grabbing another neutral sample to bring to the baskets.
Yeah, and Arjun, what are your thoughts on this? Do you think like this sort of almost a feeder strategy is something that we'll be seeing a lot? Do you think there's like something else entirely?
Well, yeah, I mean, there's going to be a lot of different factors that we see going into play, especially once we see some more defense being put in. We don't really know what people's defensive strategies are, and that oftentimes
Mhm.
ends up changing people's autonomous patterns, especially at a higher level in worlds. So I think it's fair to say that this is going to change a lot once we do see some more robots, but I think it's a fair assumption as to where we could go.
Yeah, and you brought up defense, so I had just like another third case in which I think as we get towards the later stages of the games, like in the last minute or so, where we'll see a lot of the elements disappearing and also a lot of the samples being pushed towards the center of the field. I think this is where we're going to see a lot more robot interaction. And you can kind of see that up in the lower part of the field towards the center, where both the blue and orange arrows are like they're going right towards the center of that submersible zone, and I think that's going to be really huge, and we're going to see a lot of robot contact there. Yeah, anything else you want to add as far as strategy goes, Arjun, or all good?
Oh, yeah, it's all good. This is going to be one real fun game to watch. I think there's going to be a lot of contact, a lot of robots falling down everywhere. It'll be interesting.
Yeah. Okay, I think with that we can move on from our general game strategy. We have a lot of other topics to talk about. Tyler, why don't we start our first giveaway?
Hey, everybody, sorry for all the background noise, but let's start our first giveaway of the day. So it's going to be from our friends at Spark Fun, who are a new supplier coming in. We are so excited to have Spark Fun, a part of Fun FTC. So this is the optical tracking odometry sensor. It is perfect for FTC teams. So much more compact than odometry wheels. Can be positioned anywhere under your robot, making hardware integration significantly easier while offering comparable performance to it. So if you're interested in winning this, type Spark Fun in chat right now. That's your opportunity to win. If you're a subscriber on YouTube, if you're not, hit that subscribe button right now. You get 3 times chance to win. We'll draw for that in a little bit. Thanks to Spark Fun for the awesome giveaway, and we'll see who wins this. Back to you.
Yeah. Awesome. Thanks, Tyler. So now that we've talked about like general game strategy, be it, and Miriam touched on some different types of robots, what I want to focus on are collecting samples and specimens. I think there are a ton of different ways to pick up samples this year, and I think it'll lead to a lot of really interesting designs. There's a couple things that I think teams really need to consider, though. First is the samples are going to be randomly arranged in the submersible zone, right? So this is completely different from last year's game where you knew exactly how the pixels were going to be placed. And so teams may have to drive at weird angles to pick them up or have really wide margins of error. Thankfully, the samples are pretty smooth, so they slide against the floor well, like pixels. So I think they can be reoriented fairly easily. Another thing is that like teams will definitely be thinking about, claw versus active intake versus other types of intake. Um, but I think one thing that's important to consider is whether you want to transfer the sample or not. That can lead to a lot of different discussions and designs within your team. And that's something really important that you should consider when going with the design of your robot. Miriam, what are your thoughts on as far as like the whole pass through design goes? Do you think it's going to be super viable? Do you see something else coming about this year?
Yeah, so I think the pass-through is definitely has some merit. The main reason why I personally like the pass-through is because with whether you're going for specimen or just samples in the baskets, either way, you're intaking on the opposite side that you want to outtake, and that generally leads to it being good for some kind of pass through. That being said, you don't you don't like a pass through like robot doesn't necessarily need to just like to have a transfer. Like I did see a robot going pretty far with like something like a simple arm um,
Mhm.
that can just
So
rotate over.
yeah, as a counterpoint to that though, with the whole samples, right? You're gonna intake on one side, deposit it on the other, but then you also have to intake from that side to then pick up like the newly made specimen, right? So Arjun, what are your thoughts on that? Do you think we'll see a lot more arms and things like that, or turrets, or what do you think?
Yeah, so I think that's a good point you brought up. I feel like the kind of overall design picture we're going to see among teams is going to be an intake and an outtake, obviously. So we're going to have, well, what I was picturing really with my team was that we were going to have some kind of slides that kind of pop out, and then you have slides that kind of extend out for your top. So I don't know if a turret exactly would be the best way to go in this game, because again, I see it personally is going to have it's going to have a lot of defense in play. You're going to see robots moving around, especially with all the lines, neutral zones. I wouldn't say that having a turret or keeping your extension deployed for too long is going to be the best strategy in this
Mhm.
series game. So yeah, we're really going to have to wait and see exactly how it plays out in terms of defensive strategy and how your subsystem is going to go.
Sure. So now talking specifically about intakes and collecting samples, I saw pretty much three main designs: a basic claw, a top roller intake, as well as a side roller intake. So I'll spend a bit of time on each one. Starting with the claw, they're always interesting choices for intakes. They tend to be very light, they're very fast to build, so you can have a ton of driver practice, and they are really easy to iterate, right? So if you start with a claw that's just like this, you can add a lot of features, whether it be some sort of pitch or roll mechanism, or you can add like small quality of life upgrades like centering features or something to align really well, or sensors. There's just a bunch of ways you can improve upon a claw really easily. We've already seen some very effective claw designs from our robot in 30 hours teams. So we'll have that up on the screen. But I think claws are always a fantastic way to go, and this year they could definitely be viable. But dealing with that whole random orientation aspect of the samples is going to be very critical. I do think there are a lot of solutions to that, though. Another popular option is the top roller intake. This has been very popular in Center Stage, Freight Frenzy, and Rover Ruckus. Big advantage of these intakes are that they have very wide margins of error, so you can kind of just bulldoze into the submersible zone, and odds are you'll end up with something in your intake. Now, especially with this year's game, you have to make sure that it's not a sample of the other lines. Then you have to spit it out, go for a new one, and that's just like a whole process. I do think though that they're just very fast and they have very wide margins of error. On the other side, though, I think they have additional weight and mechanical complexity. These can lead to issues or longer development times, which is just something teams will have to consider. But we can see on the screen here, like there's already very simple top roller intake designs, and they're very effective, and they have huge potential for improvement. Arjun, what do you think just between like these two styles of intake, claw versus a top roller?
Yeah, I'm going to declare my bias. I'm really biased towards type of TPU, like TPU kind of rotating wheels and those types of active intakes, because I feel like they're a
Hmm.
lot more reliable compared to surgical tubing. I personally had very bad experiences in terms of surgical tubing. It ends up in every which way. I like the reliability really of having a TPU roller. It goes down, you can see where it's going. Very little, it's very predictable. So
Hmm.
yeah, I think
Yeah,
that's a
and
good.
you brought up a good point about like you can see where stuff is going. I saw the field, and I think visibility is going to be a huge factor in this game that teams really have to take into account. Miriam, what are your thoughts on that?
Yeah, so I think visibility is definitely going to be a problem. Yeah, when I was looking at the field earlier today, I stood in the driver stations, and it. I could tell that, like, especially with robots on the field, it would be hard to see. Something that I do think can teams will use to their advantage for intaking samples is computer vision. So you'll notice that the different colors of samples are all very unique colors. Red, blue, and yellow are in very different parts of the color wheel, which opens up a major it opens up a major door for computer vision. So I
Hmm.
think that is something teams are definitely going to benefit from, because that allows a lot of, like you can use, like, Limelight is now legal this year. There's also like Husky Lens, or you can just use a regular webcam. There are lots of tools out there that are becoming legal recently for
Hmm.
teams to be able to use in order to start detecting different colors. So I think that is something that I hope many teams will use to their advantage, and be able to be able to pick up the correct color with their camera.
Yeah, for sure. And yeah, now, going on to the third type of intake, I think computer vision and sensors in general would work well for all of these. The last type of intake I want to talk about tonight are side roller intakes. So these were most common in Skystone and Relic Recovery. So it's definitely been some time since we've seen them in commonplace, but I think they could definitely make a comeback this year. I think the big advantages of these are their form factor. They really lend themselves well to long game elements like we have this year. And also, when they're sprung, I think they're super, super versatile. Like we saw in Skystone that really good side roller intakes would have no problem picking up Skystones that were oriented like in the complete wrong orientation and correct them very quickly and take them into the robots. I think there's huge potential here. Now, as far as downsides go, there's definitely some mechanical complexity that comes along with them. Like typically, you need either two motors or two servos to power either side, or a complex transmission to do both with one motor or one servo. There's also definitely some prototyping time involved here just because there are so many different options for wheels, rollers, belts, chains, just every single component of these side roller intakes. There's so many different factors. But I think they're very well known to be effective for elements similar to our samples. I think also, Miriam, you touched on this earlier, but again, I just want to reiterate teams can't forget that because they can only hold one sample or specimen at a time, figuring out the color of that specimen is really, really important. And if it's the wrong color, how are you going to get rid of it, right? Because although just like letting go of it with a claw or spitting it back out is very easy, it doesn't lend itself well to picking up another element or another sample very quickly. Arjun, what are your thoughts on that?
Yeah, yeah, I could see that definitely becoming an issue. Maybe later on, maybe I guess you could find ways to design around it. But yeah, I think definitely you have some valid points. It could be kind of an issue in terms of depositing because that's
Mhm,
kind of where you lose the accuracy. So I would prefer a claw in that type of
mhm.
context.
Yeah. And Miriam, do you think there's like any other intake types or sensors that would be really good for intakes that we haven't talked about so far?
Yeah, so I think we touched on all the major intake types that I can think of, not being a hardware person, but I think, yeah, sensors, I think, definitely are going to be huge in this game. I talked about computer vision earlier. I think that's going to be very beneficial to teams. Even if you aren't implementing computer vision, even just like a color sensor in your intake so that you can spit out the samples. Right away, if you accidentally pick up the wrong one. It won't be quite as efficient, but is definitely something that less experienced teams who don't want to mess with computer vision can look into, because you are
Mhm.
allowed to have momentary control of any type of sample.
Yeah. Awesome. So with that, I think we can draw for our first giveaway. Tyler, why don't you take it away?
Sure. Once again, that was for the Spark Fun sensor on here. We got a lot of background noise going on with the Robot 30-hour stream, so mind that. That's for the optical tracking odometry sensor. If you win, please go to funroboticsnetwork.com/winner, and the winner is going to be Mason Stewart. Congratulations, Mason. Go to funroboticsnetwork.com/winner in order to claim. And we're going to start our second giveaway actually right away, too. So let's go ahead and do that from our friends at Studica Robotics, who are going to be giving away the 100 millimeter Slim Macadam wheel set on there. So this is the includes 2 left and 2 right wheels with steel ball bearings. You might have watched on the Robot 30-hour stream. They had that running. It looked really slick. So this has blue steel frames, 12 black rollers set at 45-degree angles for smooth omnidirectional movement. If you're interested in winning this, type SLIM in chat. That's your opportunity to win that. And if you're also interested, they are giving away free samples on their website of their structure and team discounts. So scan that QR code on screen right now, type SLIM in chat, and good luck to everybody on this giveaway.
Great. Thank you so much, Tyler. So yeah, now we're going to get started talking about some hang strategies, mechanisms, things like that. And remember, if you guys have any questions, put them in the YouTube chat. We'll try to get to them. And if not, we have the Q&A coming up after this. So definitely ask them there again. Arjun, why don't you give us a bit of information about hang mechanisms?
Yeah, thank you, boss. You had some really exciting thoughts on collecting the specimens and different types of ideas along with Miriam. So kind of segueing into what a hang could look like and into the deep, I had a few thoughts. This year will be a year to remember, and I expect many highlights, and all the teams will have a very unique approach to this year's hanging challenge. It's kind of a one-of-a-kind game this year, and we expect the hanging aspect to be 100% the most unique part of this game. This type of ladder-like climbing has previously been seen in FRC, but not really in FRC. Sorry, not really in FTC. I can imagine many teams will get inspiration from various FRC approaches to hanging, and I'll display a few and kind of walk through it. So, yeah. We can play through video 1 now.
Yeah, it's already running, so just go ahead and...
So FRC 2554 Cheesy Poops from 2014 displays hanging with hooks on each side of their slides, and the robot kind of moves up slowly as per hook. I can see this kind of approach becoming popular due to ease of accessibility, and you can kind of modify the inserts on your slides. So I know a lot of teams put together extensions together on their Masumis, for example, and they use inserts in between them. So these types of inserts can be modified for a type of hanging mechanism, and you can definitely use that to hang. Anything PLA, really 3D printed parts, it should be able to hold up these types of, it should be able to hold up.
So, Arjun, I have a question for you with this. Like, I think with this year, obviously, with the 43 inches on the high basket, you pretty much need a mechanism that goes up that high anyways. But with the whole requirement of having to hang on the low rung before going to the high rung, do you think a lot of teams will be able to have a mechanism that uses just their existing slides, or will teams need a new mechanism?
Yeah, so there's a few various different options we can take, but yeah, I think it would be definitely feasible to hang on just your slides. Another approach other than just changing your inserts to a hang could be kind of adding a virtual reverse 4-bar at the end, or a virtual 4-bar, and kind of latching on from that, maybe clipping onto the next one. So that's an idea.
I see. Yeah, and do you think we'll see like any other hanging mechanisms, or like do you think there'll just be like a very clear meta for hang?
No, I think we're going to see a lot of different variations because there's a lot of different ways teams think. I mean, every person really thinks differently on how they want to do things, like in the challenge or this every day. People always have different types of thoughts. So, yeah.
Okay, yeah. So why don't you talk about the next mechanism then?
Thank you. I could see this kind of, I could also see this kind of clamping mechanism being shown, kind of expanding on what you're saying before, Aabhas, by FRC 41114 in 2022 be implemented in FTC. You wouldn't need as long slides, but you could basically keep clamping down on the bar and then extending your slides up and just really start repeating the process. It's very clean. It's very fast execution. And I think this approach would, however, be a little bit complicated to get perfectly right. As you can see, there's a little bit of a swinging motion as well, so it could add some variability in the game. So it wouldn't be as consistent as the previous one. But yeah, I think you could fairly easy to do with the high torque servo too. And a lot of inspiration to gain from hanging mechanisms for FRC's hanging mechanisms for this year's challenge.
Yeah, and so Miriam, from a software perspective, do you think we'll see a lot of automated hangs where teams kind of just line up, press one button, and go, or will it be a very manual process?
I mean, I think it could really go either way. So, I mean, hanging is the type of thing where I don't see like any major pros and cons to both. I mean, automation, yes, it's one fewer thing for the drivers to think about, but there isn't
Mhm.
really anything there that I don't think can be done manually, other than the drivers are under a lot of stress. But at the same time, so yeah, I mean, drivers are under a lot of stress, and so you automate it. So automating it could definitely help with that, and reduce human error. But at the same time, I don't think automating a hang is a top software priority, given that teams have limited time to work on their robot.
For sure. All right, and Arjun, I think you had at least one more other style of hang, and this is
Yeah.
drawing more from FTC inspiration. So why don't you go ahead and talk about that?
Yeah, exactly. So FTC 3101 during Rover Ruckus had a pretty unique hang with them using their entire robot to kind of fold up, similar to a foldable chair. I thought it was pretty interesting to see, and I think hopefully we get some outliers this season that bring this sort of character into the game. It's always really fun to see various teams always trying to figure out new things that end up working for them. Really, so creativity is something that's always awesome, and I'm sure we're going to see a lot of it this year. So yeah.
Mhm. Yeah, I think it's gonna be tough to get a rotational mechanism like this because of the two-stage hang. You'd kind of have to rotate up and then flip again. But I'm sure some team will be able to do it, and it will be very cool when they do. Yeah, and I think there is one final hang or thing that could happen with hang you wanted to talk about. Why don't we go ahead and mention that, Urgent?
Yeah, so FRC 3636 during the 2022 season posted this on YouTube. I thought it was really pretty funny. We can probably see some of these regularly in games, so make sure to get your cameras out. But it'll be more fun to watch the game this year for sure. There's a lot of teams, a lot of different things to learn from. I'm looking forward to seeing how this year's games play out, and I think with the rest of the hosts as well. Yeah, that's awesome. If you really want to,
Yeah, I really hope we don't have robots falling. But if they do, hopefully it's okay with the teams and there's no issues. Yeah, Miriam, any thoughts you want to add about hanging mechanisms?
Yeah, so I think hanging this year, it's definitely going to be a challenge. So the main thing I'm curious about is Arjun touched on this a little, but because you need to be able to be completely not supported by the tile floor or really anything other than the low rung before you can attempt to reach for the high rung. And so I think that'll come with some very interesting strategies of how teams will stabilize themselves in order to get to the high rung once they're already on the low rung. So
Hmm.
yeah, so I mean, you could. So I'm wondering, will teams go for something super stable where they can just go straight up, or if a team could potentially try to like put out an extendo or something and try to use the swing to their advantage in order
Hmm.
to grasp the high rung.
For sure. All right, I think that's enough of a discussion about hang and everything else. We'll have a ton more analysis and videos coming out throughout the season. But before we wrap up for tonight, Tyler, let's draw for the second giveaway.
Yeah, once again, that was from our friends at Studica Robotics who are doing that giveaway. We'll bring that up on screen in just a moment here for the awesome Mechanima wheel set. Like I said, if you haven't really seen this in action, watch the Robot 30-hour stream later on. It is really cool. And don't forget to scan that QR code if you want to get some free structure samples and also some exclusive team discounts. The winner of that, by the way, if you win, please go to funroboticsnetwork.com/winner is going to be Scott Miller. Congratulations, Scott. Make sure you go to funroboticsnetwork.com/winner in order to claim. And if you are watching live, we're going to have more giveaways during the Robot 30 Hours Day 1 recap coming up in just a little bit.
All right, thank you very much, Tyler. Miriam, why don't you lead us out?
Thank you to everyone who tuned in and to those who hit the subscribe and like button. Please check out the new fun and robotics merch below this video and let us know in the comments what strategies you think will come out of this game. If you want to stay connected to what Fun FTC is doing, follow us on Instagram, Facebook, and X under @FunFTC and TikTok under Fun Robotics Network, and join our Discord through the link in the chat.
Yeah, and on behalf of myself, Miriam, Arjun, and our producer Tyler working behind the scenes, I'd like to thank you all for tuning in tonight. Please keep an eye out for future new FTC content coming on YouTube, our exciting Robot in 30 Hours stream, and just everything else we have going on this weekend and this season on YouTube. Thank you so much, guys. Bye bye.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineered their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Studica Robotics offers durable, polished, and anodized aluminum channels with several new colors coming soon to customize your robot at studica.com/robots. No rough edges and a versatile hole pattern allows for positioning at multiple angles. Feel the Studica Robotics difference, and if you're in the USA, request a structure sample for your team at studica.com/robots.